With the use of the specific values, let's try to evaluate algebraic expressions. Taking into consideration the given values for each variable, we could come up with a representative value for any expression. Why I say representative? Because don't forget for the fact that each variable could take any other values. As for these given items here, let's try to evaluate them using the given values of the variables. So for number one, we are going to solve or give the value for the expression 2p squared when p is equal to -1. Again, this is only for the value of p when it is -1. If we are going to change the value for p, let's say 0, 2, 1 million, square root of 5, 1 half, -1 third, we have different values for the given expression. So let's just try to focus only on what is given here. But again, p may not be -1 on the rest of the items, just for this number only. So for this one, the process when evaluating algebraic expression is the process of substitution. Substitution, in other sense, is that we are going to replace the variable with a given value. Replace, change, substitute. Okay, the variable with a given value. So let's talk about number one. The suggestion here or my advice is whenever you're going to evaluate algebraic expressions, do not be too hesitant to use parentheses because this will help you understand later on the correct operations, especially if you deal with negative um, values, just like what will happen here in number one. So in our expression, 2 will still be 2, but p will become -1. If you're not going to make parentheses, it may look like this, -1, and you have here squared. What does it look like? It looks like you're just squaring 1, and the negative sign will become an operation. So it will be 2 minus the square of 1, which is still 1. 2 minus 1, you will have the result of 1, which is really incorrect. That is why always use parentheses. Another thing, there is a different value in any of the calculators if you have here -1 squared and the expression when it has parentheses. In other calculators, this first expression will result to -1, and this second here will result to 1. Why? Because some of the calculators will treat this expression to be squared first before the negative sign. That's the problem for some calculators. So it is now more appropriate if we are going to have parentheses, so just like in the second form, because it means that we are squaring the whole value, which is -1, not just one, but including the negative sign. Because if we talk about squaring of a negative number, we are just multiplying the number by itself twice. So negative times negative will become positive. 1 times 1, 1. So again, I'm emphasizing the use of parentheses. And do not worry, you just need to rush. The first step is only for substitution. The second step is not to simplify. This means we need to use the proper op, um, procedure of operations, GEMDAS. This means we start with the grouping symbol if there are or items inside the grouping symbol, and then let's proceed to exponentiation. And again, MDAS doesn't mean multiplication above division or addition above subtraction. It's MD, whichever comes first, AS, whichever comes first. So in this case, let's start with exponentiation rather than multiplying the coefficient here. So it's still 2. Let's use the red color, 2. And then the square of 1, or the square of negative 1 rather, using parentheses, will result to positive 1. And finally, 2 times 1, the answer is 2. So for number 1, the expression 2p squared when p is negative 1 will result to 2. This may not be true if we are going to change the value of p for other values. As I've mentioned, there are infinitely many real numbers. Let's proceed to number 2. To do this again, need to substitute first the variable. So you have here 3, and then again the use of parentheses, because if you will not, it will look like this. And then 37 minus 4 is 33. No, again parentheses. And then the correct flow of GEMDAS. 3 times 7, 21. And you have here minus 4, which is actually equal to 17. Before we proceed to other items for 3, 4, and 5, I would like to emphasize one important thing here. Even if we are already in algebra, look at the first steps. After substituting the values for the variable, they look like the operations on real numbers we are able to discuss in the previous grading. So you need to always remember what are those important concepts to multiply, add, subtract, divide, or express a real number into its exponentiation, such as square and cube and so on and so forth. So you just need to review on that. I'm also talking about other concepts when we proceed to number 3. Because as you can see, in number 3, our denominator for our expression has this symbol here. And that symbol is for the absolute value notation, also discussed in the previous grading. But you don't need to worry about that one. First, substitute the values. Now here we have two different variables, a and b, and they have specific values. Do not interchange them. It would mean that when we substitute the value for a, that's 2 times 4 using parentheses, and the denominator will become the absolute value of negative 2. After substituting, let's try to get the value, or the simplified value for this. Let me just copy first the numerator. Let me not simplify them. I would like to start with the absolute value notation in the denominator. And we talk about absolute value notation, it's we are getting the positive value of whatever is inside the notation. And the absolute value of negative 2 is positive 2. The other reason why I did not multiply 2 and 4 to have 8 is because we could apply here the cancellation law. The cancellation law is for multiplication. Cancellation law for multiplication. Since the 2 and 4 in the numerator are separated by multiplication. But if it's 2 plus 4, 2 plus 4, you cannot do that, okay? Because there's no cancellation law for addition. It's cancellation law for multiplication. Hence, after using the cancellation law, I have here the result of 4. Or if you don't like the cancellation law and you would like the other step, of course you could multiply 2 times 4, which will yield to 8, and divide by 2. And its lowest terms is actually 4 over 1. Or you just need to skip the denominator of 1, because here unit fraction, or we could this is a unit fraction, or we could write it as an integer, which is 4. Nevertheless, with the use of the cancellation law for multiplication, or this method here, they yield the same result of 4. But what made this possible? The process of substitution. And then make sure that you can always be guided with whatever operations you have learned in the previous grading. Let's continue with number 4. In number 4, y is a 3. So simply substitute. You have 3 squared minus 4 times 3, and you have your plus 6. This is your first step only. by substituting the value for the variable. And then proceed with the simplified result. When you say 3 squared, it's again 3 times 3, which is actually 9. Minus 4 times 3 is 12. And you have here plus 6. MDAS. I would like to emphasize, do not add this first because you might say A is written first before S, so I would add first before subtract. No, MDAS, specifically AS, is the process when there are no other operations aside from the two addition and subtraction, you start from left to right, strictly left to right. And that would mean we start first with 9 minus 12, which is negative 3, copy plus 6, and then negative 3 plus 6 is actually equal to 3. So this is now the answer for number 4 if y is equal to 3. If we give another value for y, it's then definitely we'll have a different result. The number 5 item is, I believe, the most complicated item for this pre-wake session. So let me increase spaces here so that I could write more steps. As I have mentioned, steps, you don't need to rush, simply start have it step by step. We have values here for A, B, and C for this expression. By the way, if you are not familiar with this is one part of the quadratic formula that you will actually mingle with soon as you continue your journey in your high school math. So I am just sharing you this so that you would understand that whatever you're doing right now, concentrate on it, give your focus because it will help you understand better items later on. For number 5, we'll start with negative b. So now you have here negative and you have b. Do not say negative 6 because it's negative b. You just simply need to substitute the value for b, which is in fact still a negative 6. So it's a negative of b, so it would be negative of negative 6. Again, negative here is already a part of the formula, and we will have a value for b, which is also a negative, so it should look like this. And we have plus, this is square root. Again, don't worry, let's do it step by step. You have b squared. So you have negative 6 squared minus 4. The operation separating 4a and c is multiplication. So it would not hurt us to use parentheses. A is 1, c is 5. Okay? All over your 2a. So you have 2 times a, which is 1. That's just the first part, substitution. It may look too complicated, but don't worry. Let's do it step by step. The first step I'm talking about here is the property that represents two negative signs written side by side. The double negative property allows us to have the two negative signs written side by side under multiplication to become positive. So instead of negative 6, it will be just be positive 6 plus here square root. Don't worry about that. 6 negative 6 squared is actually negative 6 times negative 6, which will yield to positive 36. So you have here 36 minus 4 times 1 is 4 times 5, you will have 20. All over 2 times 1, which is 2. Let me erase the extension here. Okay. After that, again, GEMDAS. Do not add, do not divide. We start first with the grouping symbol here inside this root symbol. GEMDAS allows us to copy all items which are not part of the grouping symbol. So it will become 6 plus the square root of 36 minus 20. You'll have 16 all over 2. And then you start with the square root of 16, which is actually positive 4 all over 2. May I repeat? Do not do this and say 2, which will yield to 8. Do not do that since there is no cancellation law for addition. The terms on the numerator are separate by addition, so you cannot do that. But what we could do here is to add the numerator. 6 plus 4, you'll have 10. Divide by 2, which will then give us the value for 5. So the process here, number 5, it may look complicated or long. The first step is always substitution, and you go from there, go with MDAS, or GEMDAS rather, and then slowly by slowly have the values here. We are just lucky that in this expression, the principal root is a rational number, which is 4. However, if and only if this is not a perfect square number, let's say 26, this should be considered as your final answer. No need to give the answers in decimal notation because in the first place, irrational numbers do not end and do not repeat a pattern. So if it's 26, so it stays as it is. But since it's not, that's why we have the final result. This is how we evaluate algebraic expressions. Kindly try to re-answer this, but give other values for p, x, a and b, and y, including c. See ya!